previous video, we set up a navigation mesh that does a good job of defining the traversable space for a human-sized character that moves along the ground. But what if we wanted to add another character that was much larger, or one that could swim, or fly? We could solve this problem by creating new NavMesh agent definitions and configuring each one to define the different dimensions and movement capabilities of the new character. Agent is a generic term, meaning any form of autonomous entity within an environment, and in our case, refers to any AI character that we create. We'll take a look at how to create these agent definitions, and how we can use them to support multiple nav meshes within the same level. We'll begin by selecting the Recast Nav Mesh from the World Outliner. We'll find the Generation rollout within the Details panel, and note that there are several options here related to the agent. We have Agent Radius, Agent Height, Agent Max Height, Agent Max Slope, and Agent Max Step Height. So that we can visualize the effect these changes will have on the navigation mesh, we need to re-enable the Navigation Show flag from the Viewport toolbar. With the nav mesh now visible, let's reposition the viewport camera to take a closer look at the thin section on top of the walkway. Let's take a closer look at the Agent Radius. Currently, it has a value of 35. Let's see how that compares to our AI character. Open our AI character by selecting AI third-person character from the content browser and double-clicking to open it. With the Blueprint Editor open, move to the Viewport tab, and then in the Components panel on the left-hand side, select the Capsule component. Move over to the Details panel, and in the Shape rollout, note that the capsule radius is currently set to a value of 42. Minimize the Blueprint Editor to return to the main editor window, and change the agent radius from a value of 35 to a value of 42. Note how the section on top of the walkway here gets thinner. We could continue to increase this size until eventually, this walkway section of NavMesh would disappear completely. However, as this value doesn't match the collision value for our AI character, I'll return it to a value of 42. The next value to look at is Agent Height. I'll reposition the camera once more to take a look at one of our static mesh objects next to our character. I'll begin by selecting one of the cube meshes and using the Move tool to raise the object above the ground. Note that when I raise the object a little way off the ground like this, the nav mesh underneath fills in, indicating that the area should be traversable. However, if I use our player character here as a guide and move them underneath the surface, we'll see that there's not actually space for them to fit. This means we will end up in a situation where our AI character believes they can traverse to a space but won't actually be able to get there. This is obviously not desirable. We can fix this by returning to our Recast Nav Mesh and adjusting the Agent Height value. So let's do that now. Looking at the Agent Height value, it's currently set to a value of 144. Let's return back to our AI third-person character and compare the value there. With our capsule component still selected, we'll return to the Shape rollout and look at the capsule half height. We will take this capsule half height and multiply it by 2 because we want the entire height, giving us a value of 192. If we minimize this blueprint again and return to the main viewport, we can adjust the agent height value to 192. When we do this, note that as we would hope, the nav mesh is cut out, indicating this area is not traversable by an AI character. If we reselect this mesh and use the Move tool to raise it higher, up above the capsule, if we then reselect the static mesh and raise it higher above the character, we will see that the nav mesh will once again fill in, indicating that this area is traversable. While we have been adjusting all of these values from the Recast Nav Mesh, they can also be adjusted from the Project Settings window. So let's open the Project Settings window now. The quickest way to find this is by typing Agent into the search bar. In the Engine Navigation Mesh section, under the Generation rollout, we can see the same options as before: Agent Radius, Agent Height, Agent Max Height, Agent Max Slope, and Agent Max Step Height. Note that adjusting the values here will adjust them in the Recast Nav Mesh, and vice versa, as we're really adjusting the same values. While we still have the project settings open, let's take a look at one more option that would allow us to have multiple agent types with multiple sets of these values that we've just defined. Begin by clearing the previous search term, and then locate Engine, Navigation System, and from the Navigation System, note we have an Agent Rollout section at the bottom. We have one option, supported agents. The supported agents value is actually an array which we can add elements to. Let's add a few for example now. If we expand one of these new elements, among other options, we can see that we have agent radius, agent height, agent step height, and a number of other variables that we could turn on or off, for example, flying, swimming, walking, and the ability to jump or crouch. For the rest of the project, we'll work under the assumption that there is a single agent type, but I think it's very important to know that you do not have to limit yourself to this. It is possible to add as many different agents as you like, and each one can use a different NavMesh. In this video, we have discussed what NavMesh agents are used for, to define the size and movement capabilities of AI-controlled characters. This information can then be used by the NavMesh generation to create a mesh suitable for that character type. We also learned that we can place multiple navigation meshes within a single level and assign different agents to each mesh.